Hi everyone, how are you?
Hello.
Hi Ryan. So we're gonna do lab 9 today. If you want to take a look at it. Hi Tobin, how are you? I'm hanging in there. The day just passes by so fast. Hi Jason. Hi everyone. Everybody's doing good, I hope. Okay, so check out Canvas Lab 9. We're gonna do Zeller's formula today. Hi Alex. Hi Ken. Hi everybody. So we're going to work on lab 9. Take a look at it on Canvas. I posted the code. It's a little long, so I'll explain what we have to do. Okay. So this one's a little harder. It built on the one that we did before. So if you want to take a look at it. And also I posted lab 5 exercise 2 solution. Let me double check on that. Okay. Sometimes I forget to click publish because it should be. Yeah, so month of the year, and then I still have to add the credit for those of you who turn it in. So the code for that is on the page for lab 5, exercise 2. Okay, so just want to double check on my dog and make sure that she's not throwing up. Okay. So the chapter that we're doing is going to be chapter 9. I'm sorry. Are you asking, Louis, of which chapter? So I'm going to type in the chat, okay? So solution for number 2 of lab 5, which is month of the year, is in module 5, unit 5 module on the lab page. We're currently doing lab 9. So exercise 2 of lab 5 was an extra credit. This is the week that I had to go to Virginia. And so I told you if you did it in the past, you would get the credit. So I'm no longer accepting extra credit for that. The students that turn in the extra credit, there were quite a few people that turned it in. I will add that into your extra credit. Okay. So now, right now, we're going to talk about lab 9, which takes a little bit of time to go over. So I'm going to go into screen share. And we are going to look at lab 9, which is compute the day of the week using Zeller's formula. This is the one that we're going to work on right now. Okay. So if you recall, in lab 5, we did day of the week, and we asked the user to input a number, and it's going to output the day of the week. Today, what we're going to do is we are going to work on setting the value in a certain memory location, and it's going to give us in the console, okay, in the console, the day of the week. So it's going to look like this. After you set the value, then you run the program, then it's going to tell you based on the date that you set, what day of the week it is. Okay, so let's talk about the actual assignment. Let me zoom in real quick. Okay, so based on this lab, the given problem statement is that we are to write an LC3 program that's given the day, the month, and the year. So this needs to be set in the memory location. So your input would be here, okay? So don't forget to do that at the end after you finish the program. Before you run it, you have to set it, okay? Then after you set the value at these locations, and I will show you how you can do that, then you can run the program, and then you're going to check your console, and it's going to tell you what day it is based on the value you set. So the input will be at location hex 31F0. That's going to be the month. Hex 31F1, that's going to be the day. And hex 31F2, that's going to be the year. And we need to convert the decimal value of our year into hexadecimal because you know simulator will not take decimal value. So we need to make sure that when we set our value for input, it needs to be in hexadecimal value. So if you think about a date like your birthday, and if your birthday is a decimal value, you need to use a calculator, okay, and convert it to the month and the year for with hexadecimal value. So here it tells us that this is the location to store our month. Okay, this is the location to store the day, and this is the location for our year. Okay, now if you look at how it's set up, something like this, okay, but we're not filling anything that will be like this, okay, but what they're saying is that when you set up the date, you need to make sure that it's spread out to these locations, and you need to input those value in hexadecimal. So if we're looking at June 1st, 2005, the month of June is going to be hex 6. Hex 6 needs to be at 31F0. Then the day, the first one is going to be hex 1. That's going to be at the location 31F1. Then the year, if you're looking at 2005, what you need to do is you need to go into your programmer calculator, okay? And then you're going to input decimal 2005 and look at the hex value, and this is going to be the input that you set in your simulator, okay? If you don't do that, you're going to get the wrong answer, and then it will not match up with the actual day that occurred in the past. So we're going to actually check what day it is, right, of the week based on the given date. So the output, you would see the output in your console for the days of the week, okay? So then the Sunday would be considered as 0. So what you should see is in your console again, you should see something like Monday, Tuesday, Wednesday, Thursday, Friday, like what I have here, okay? I have it for the date that I gave it. It gave me Sunday, and that checked out, okay? Any question with that on how the program should be outputting?
Yeah.
Okay,
So we put in the number like 0 through 6, and then it prints the days. Is this what
no,
you're? Oh no.
No. So again, at your location, okay, let me show this now. And I intended. So here's my simulator, okay? I'm going to go ahead and load my program. And before I run it, I need to click the set value. And the first location is going to be the month. So we're going to do a hex 31 F0. And let's say that I wanted to put the month, let's say June. Okay, so that will be hex 6 for June. Okay, apply. Then in the next location, which is the day, let's say we wanted to put June 1st. So 1 is going to be in the location for the day. Apply. Then for the year, as we calculated 2005 is equivalent to hex 7D5. So when you set the year, that will be in the next location, which is hex 31F2. And then you type in the year, which you calculated here, 7D5. So we would do hex 7D5. And then click apply, click OK, and then you run. So after you run the program, right, it should give you the output. I have to reload my program, I'm sorry, but it should tell you what day it is that you're looking at. Okay. All right. So we're clear on the output.
Yeah.
All right, good. Okay. So we're not doing it like the old lab. The old lab is when we put in the 0 through 6 or 0 through 9 number. We're not doing that. We have to set the location with the hex value. So let's talk about the program itself. So the program is intended that we are given a date, let's say January 1st, 1900, and it should tell us what day of the week it is. So that should be on Monday, right? And the way that you can check this is you can use Google and you can say what day is this, right? And it should tell you what day it is. So on these websites, they have to program these in. And what we're doing is we're going to do it in LC3. Okay, we wanted to check. So if you type in if you set your birthday with the month, the day, and the year, it should tell you what day of the week you were born on. Okay, so the way that we would do this is we would use Zeller's formula. And Zeller's formula allow us to be able to calculate the day of the week based on the given month, day, and year. So this is the Zeller formula, right? So you have F is equal to K plus 13M minus 1 divided by 5 plus D divided by 4 plus C divided by 4 minus 2C. So if you look at it, it's all arithmetic, right? We already done multiplication. We already done division. So, and we've done addition and subtraction. So we can definitely do this in LC3. So, and the K here represents the day of the month, okay? Like if we're looking at January 1st, that would be the 1. And the month is going to be represented with M. So this is why we do a 13 times M, okay? So here it tells us that M is the month number designated in this way. If you have March is 1, then April is 2. Then at the end, you have December is 10 and January is 11 and 12. So unlike your regular month that we look at, like January is the 1st, you disregard that. The way that we look at the month when we use this formula is the month that's going to start with the first month, that's 1, is going to be March, okay? And February is going to be in number 12. So when you multiply it, in this formula, you would get an output for your day of the week. Okay. So then with this formula, you have to implement this condition. These conditions need to go into your program. Okay. So it says that X is the usual month number, right? Like the way we look at it is January 1st is 1, February X is 2, and so on. So we need to interpret that, tying it back to Zeller formula on how we human look at the first, the number 1 is January. And the way that we incorporate this is using a second formula is M is equal to X plus 21 mod 12 plus 1. Okay, so what you need to do is you need to incorporate this formula for M, right? It's like how you solve an algebra. You say M is equal to this, then you would plug this into for M to be able to solve the rest of the equation. So then we would say that using this equation, the second equation, we would have M is equal to X plus 10 if X is less than and equal to 2. Okay. Recall that when we look at the previous criteria for the month, right? Look at February, that's going to be 12, right? And if we look at this over here, if you have 12 as in February, that will be 2 plus 10. That's going to give you 12. So in the case of the month, right, if X is less than and equal to 2, you're going to take X plus 10. And then the second condition, the else condition that we have to put in is when X minus 2, that's going to be anything for X is going to be outside of this if. Okay, so we have to implement this if condition, and the else is anything beyond that. Okay, so we need to tie that into the actual program itself. So if you think about that in C++, right, if you're given this, you need to initialize X at 10, right, if X is less than and equal to 2. So you would have to write the if statement, right? And then you would say that it's gonna, whatever that variable is gonna plus a 10 if it meets that condition. Else, we're gonna take X subtract 2. Okay? So here, in this one, this is the example where we would have M is equal to 4. Okay? And then when we do this, we would then plug this in for M here and then be able to solve. So it says D is the last 2 digits of the year, okay? Because the way that we use the D is that you have to break it up into 2-digit representation. So if we're looking at 1900, the first D is going to be 19, okay? And then the second part of the D is going to be the last 2 digits, okay? So here it tells us that if it is January or February for those previous year are used, then in our example, that will be 05, right? 2005, then it will be 2005. The C is going to represent your century, and that is going to represent with the 20, like what I had mentioned before. So when you're looking at how we read the year, if we're looking at 2005, right? 20 represents a century, and the D is the 05 is going to actually represent the digit for our actual year. Okay, so the way this formula works is this is going to be the actual year, and this section is going to be the century calculation. Okay, so when you understand this formula, what you see is that we're going to have the month, right? And then the year. and then the K is for the day. And using this, that's going to give us the day of the week. Okay. So in representation, we come back to what we did in lab 5. We said that 0 is a Sunday, 1 is a Monday, 2 is a Tuesday, 3 is a Wednesday, and so on. And we would have 0 through 6 for our 7 days of the week. So if we're looking at F, let's say if F is given to us at 123, if you take 123 mod 7, you would have a 4. So when you apply the mod is when we actually gonna get the value, and we need to convert that 4 into a Thursday. Okay, so when you mod, when you take the number, because you're gonna have an F value, and you would take F mod 7 because there are 7 days of the week, your remainder is going to be the value that represents the day of the week. Then we need to convert it. So there are many steps in this program that we have to really understand in how we calculate the day of the week, how we calculate the century, how we calculate the year, and how we calculate the month. Any question? So, okay, so we know that we have to implement subroutines, which are functions. And when you apply the modulus is when you need to implement it for like mod for the day. And we need to implement the integer division, the multiplication based on the given formula. And you can use subroutines, multdiv, however you wanted to name it, as long as you are able to derive the right solution and it makes sense to you. Okay. So once again, we need to save and restore register. We talked about this since last week. And so when you do that, you need to make sure that you save and restore the proper register. For the structure of the program, okay, you've seen this since our lab 5. Make sure we align these accordingly. Otherwise, your days are going to get cut off. You've seen this already in lab 5. Exercise 1. Okay. We need to then implement the subroutine, and we need to return from the subroutine. So that means that we have to do JSR and then the subroutine label, and then we're going to do the return for the subroutine. So at the end, you already have the code. So what you need to do is you need to run the program. Okay. You need to take screen capture that you have the program written and ran. And I need you to set the days, and you need to provide the screen capture for those. Okay. And I gave you the days. So, sorry. You need to determine the day of the week for March 4th, 1956. And that should be a Sunday. You need to determine July 4, 1987, what day it is. You need to determine Christmas Eve for 2000. And you need to use your birthday to check. Okay. And the way that you would check this is you can check it against the verification online, right? You can type into Google what day of the week is, right? December 24, 2000, and it will tell you, right? Because the developer actually created the calculator for that using something like Zeller formula. So use an online calendar to check. And I need you to answer this question, these questions for D. Did the output show the correct day? Okay. If it is not, okay, that means that you missed something in the code. I triple and quadruple check. Okay. So make sure that, we verify and make sure that the day is correct. What new concept did you learn out of this lab? Okay, what type of challenges did you come across in this lab? Because what we can do is we can look back into the lab and we can say, okay, I learned this and this and this, but I'm not sure if I understand it. So I need to go back and revisit that and take a look at the code and see what we've done here. And if you have difficulty, you need to brush up on that area, because if you can write this program in C++, you should be able to write it in assembly. And I understand it's a lot harder and longer in assembly, but if you can write it in another programming language, we should be able to do it in assembly at this point. Okay? Any question? So make sure that we check and include the screen capture for the days, and we need to answer these questions. Okay, so the story about this lab is that I wrote this a while ago, and I taught this class a few times with assembly, and when I ran into a little bit of issues that in my program, it had problem with interpreting some of the earlier dates. Okay, so I went back and I did some revision in my program, but one of my former students, um, he solved it, and his approach is a little bit better. He's at UCLA now. But what you see is Kevin's solution, and I wanted to explain Kevin's solution because I explained my solution and it wasn't quite complete. It wasn't good enough. Okay. And there were many students that submitted also very good solutions in the last couple of years. So what we're going to work on is we are going to work on our lab next. So I'm going to go through the lines and then the code so we can talk about it. Okay. Any question with this? So I posted the code already. Okay. And then let's go through it. So when we go through this, keep in mind that I'm going to flip back and forth, and then we're going to revisit the formula so that way that you can see. Okay, so this is the equation that we're going to use. And then, but we are going to start with this part. Okay. Okay. So this is the beginning of the program. We have the origination at 3000. We would do a load label X, and we're not, I didn't comment everything here, but you can see that we would load the label X, okay? And then we wanted to represent X minus 2. So at this point, what you have is R1 is actually equal to X minus 2, right? And what are we referring to here? What are we really doing is we are trying to determine M. And in order to determine M, we need to set up the if condition like what is shown right here, right here. Okay, so this is what we're doing now. So then we would branch for positive. And when we branch for positive, if it's if it's positive, it's gonna go to not January, February. Okay. That would be March and beyond. Then we are gonna add the 12. Okay. So to get the M, if the month is January or February. Okay. So if you look back right here, right? If you go back, and we need to represent on the other months that will be post February. That will be March until December. Okay. As February is going to be 12. Okay. Question?
Wait, Professor, so you saying like the months after in order to incorporate it in the loop, um, we're gonna be doing it from March to December, which is the 10,
Yes.
and
So
then
March is going to be your for month 1. December is going to be month 10, right? And then 11 and 12 is your January and February.
so when we're setting the values for the month, we want to put 11 for like January and then 12 for February.
Right.
Okay, I see.
Okay. So when we come back to here, right, we want to set the M. So we're going to add, right? We're going to add 12 to this because if you subtract and when you add the 12 with the -2, you get a 10, and 10 is going to give us anything post December, which is going to be January and February. Okay. Then after that, we are going to load label C. And now we want to get the label into the register so that way we can do what? We can do the Zeller formula, right? So looking back here is once you have branch already, what we want to do is we want to be able to work on this part, okay? And at the end, we would have a complete Zeller equation, okay? So now for the label, not January, February, and you can tap this out, that's fine, because we branch positive here, we gotta make sure that we state what that section is gonna be, okay? So we're gonna store register 1 to M, then we're gonna clear register 0, then we're gonna add 13 to register 0. So that's gonna allow us to get ready to multiply. Okay. So multiply M by 13 because you're gonna call the function next. Okay. Any question with this part? So if you're not sure, come back here and we already set up the M, right? Previously. So in the M, we have to state what M means, right? With the -2 and the plus 12. So that's what we had set up. After we've done that, we would then now get ready to do the multiplication. And whenever you work with an equation with assembly, you're going to work it from the inside outward. So anytime that you have the parentheses, you are going to start with that first. Okay? And then you're going to add all of the other ones. And at the end, you're going to have the complete equation. So right now, we're at 13n. Okay. So here we would add the 13 and then we call molt subroutine. So we would do a JSR molt. That's when we call the multiplication.
Wait, Professor, when I was looking through the code, I noticed like we were working through the Zeller formula before we got to the Zeller thing. Because you know how we have a Zeller in the bottom? I thought that's where we were gonna do the thing.
That's the complete.
Oh, okay.
Yeah,
Oh, so you're like kind of setting it up before you jump in,
right.
right?
It's like how you declare a variable for it. That's what we're doing. Okay. So every section, because assembly doesn't understand multiplication, we gotta piece it all together. And at the end, we're gonna have a complete equation.
Gotcha.
Okay. So then next, we're gonna add -1 to R2. Okay. And what we're doing when we do that is we're gonna set up the -1 part. okay? Because when we multiply, when we go to the we multiply, that's going to give us 13m. Then we have to add the second piece to it that will be -1 because we wanted to say 13m minus 1, right, in that parentheses. So that happens here, okay? So that's easy, right? And with this new WM, your new M, your new month is going to be holding 13m minus 1. Okay, then we copy R2 to R0. Okay, we clear R1. We add hex 5 to R1. Okay, so what are we doing there? Okay, so if you look, we're getting ready to divide. Okay, because we already finished this part in the last 2 lines. Then now we have to bring the 5 into a register so that way we can start dividing. Understand? Any question? Okay, then we call the division subroutine. So now we're dividing, okay? And then we would store register 2 to write quotient of m. Because remember, we have to mod it, we have to divide it. And the remainder, we care about the remainder because the remainder is going to tell us something about the day. Okay? So when you divide, you're always going to have 2 locations. One location is going to be for quotient, one location is going to be for remainder. Okay? So that means that at this point, your quotient of m is going to be holding this, which is a part of that equation, right? Remember, we're working from the inside the parenthesis. Now we expand to the division.
Oh, Professor, so the reason you keep reusing register 1, 0, and 2 is because that's what you have the multiplication and the division as?
Right. You
Oh, okay.
remember from the last lab. That's correct. So I'm reusing that so I don't have to, copy. Okay.
Oh, okay.
But what you can also do is you can think if you copy and you can save and restore and all of that. So it really depends on your approach
Yeah.
ultimately. But in the lab, it tells us which register to use. It tells us to use R1, R0, and R2.
Okay. Yeah, because
Okay.
I was wondering, because I kept seeing R1 getting reused, and I was like, oh, I guess we're reusing the register so that we don't have to use the other ones. But I was also confused because if we're using R1 and R0 and R2 in the code, why would we also be using it in the division? But it just makes it easier to like,
Right. To follow,
yeah,
right? Because if when you call for the subroutine, you return from it already, right? When you have that call, it's when it does that, it's going to go to that section and it's going to return. Later on, you're going to see how we handle that down here. But yeah, that way you can track your register. Sure, you can use other register, but as long as you track your register, you're fine.
Wait, so after you do either the multiplication or the division, is R1 and R0 cleared and we only have that stored value of R2?
Yeah, because ultimately when we return, we already transfer that somewhere else. Okay. So when you build out your program, when you plan out your program, like this type of program, you have to think about where, when that data is returned, where is that going into? And then can you reuse that register? Ideally, we should be able to reuse the register if it already produced an output. Okay. The last one, what we did was we save register and restore it, right? And so that's what you should be doing along the way as well. Okay. All right. So we're here at dividing by 5. We load C to register 0 because earlier, remember, we store it. So now we have to load it. Okay. Then what you're going to do is you are going to tie all of these to arbitrary location for now, right? Remember how we talked about save and restore last week? Okay, not sure, come back to that lab and looked at that. Okay. So when you AND it with the 0, okay, then you're going to AND it with the hex F. So this is going to allow us to have that register 1 ready. So when you do this, what you're doing is when you do this, you would have R1 with 100. Okay. So why do we want to get it to 100 there? If you read the comment below, right, you would have to do the division by 100 to get the year, because the way that we read the year is, right, like if you say 2005, right, it's going to be the 100th digit that you're working with. So when we're looking at the century, then you got, 2-digit for the year. That this is where you wanted to set this up for the 100 to represent the year value. Okay. So here we divided by the 100 to get the year. So we would do a JSR division. Then we need to store D to register 0. And register 0 now has the remainder, which is the last 2-digit of your year. So when we say 2005, right, 2005, so the first 2 is handled with the division, and then the 05 is going to now be the D. Okay. Then we're going to store new C to register 2. Then we're going to load, because we store D, we're going to load D to register 0. Clear R1, add hex 4. So we are getting ready to divide it by 4, where D is divided by 4. Okay. So we already got D ready, right? We added D in the last few lines. Now we're going to load 4, or we're going to add 4 to a register. So now we're going to get ready to take D and divide it by 4. So we're here. So far we complete this part. Okay. And then we also have C ready, which allows us to also divide it by 4. So what you're doing next is you get 4 to register 1. So you add it, then you do the division. Okay. After we divide, we will need to store it out to quotient of D. So quotient of D has D divided by 4. We're going to load new C to register 0. Okay, because earlier we store it, right? We're going to load it now because we need to take C, we divide it by 4, which is the next part of the equation. We're going to clear register 1. We're going to add 4 to register 1, then we divide. So that's going to give us C divided by 4. So in Kevin's code, he actually is almost exactly like mine. There's some slight difference between mine and his. Okay, I work it exactly like this as well, starting from building from the inside out. All right, so now from here, after we have C divided by 4, when we store R2 out to quotient of C, okay, then we're going to have the complete formula and we need to execute it as a subroutine together, everything. Okay. So we would have like a function, right? F. So we would have F, store that to register 0, clear register 1, add 7. And the reason why we do here add 7 is because we are going to mod 7 to get us the day. Okay, what am I talking about? Okay, so since we already set everything up right here, we load F, so, or we store F, so F would be the actual output. And then what we need to do is we need to get it to mod 7 so that way we can get the day of the week. Okay, so if you store the value to F, then you do a mod 7. So you can get these numbers, and this number is going to equal to those strings. So now we would then do the division, store that out to mod F. Then we need to, because after we mod it, the remainder is going to be our value for the day. So we need to copy register 0 to register 1 so we can represent that as a day value. Okay. Then we would load effective address. Now, why can't I keep it in register 0? Well, because register 0 is required to do an LEA. So if we do an LEA in the next step, we have to copy it to another register. Otherwise, it's going to get destroyed. Okay. So we would then load the effective address for the days with ties to the string that we declare. Okay. And we need to make sure that we loop it. So this is going to give us the counter in our loop. And to keep it displaying, we would branch it to negative. So it's going to stop when it reached the negative. Okay. Then we add hex A to register 0. Why? Because there are 10 characters for Wednesday, right? String, with the string, it's null terminated. We count up the maximum character for those days, and that will be the hex A, which is 10 locations. That's going to represent 1 for each character. Okay. Then we do a branch loop and then a put, so that way we can see in console. We would do a halt there after that. So think of this section as your main, right? But assembly is a little different in that main can be in multiple locations because we fill at the bottom and then we do call at the top. Okay, so it's slightly different than what you see with C++. So now in your subroutine definition or your function definition, you have multiply. We've done this for the last few weeks, so you should be familiar with it by now. Okay. So R1 and R0 will have the parameters, which is result in R2. So R2 is going to have the output, the result, and then we need to bring that somewhere where R0 and R1 is going to be your parameter, which is going to be what you're multiplying. So we clear R0, we branch negative and 0 to n. So go to n if there are negative or 0.
Wait, Professor, to clear the register, shouldn't it be and instead of add?
Oh, I'm sorry. This is to initialize. So it's the same.
Oh, okay.
So this is initialize R0 as 0.
Why, it already doesn't have a value stored in it?
Yeah, so if it already has the value, right, it's going to branch positive. It should have a value. So when you add 0 to it, if it's a positive, right, it's not going to end. But if it's a negative, then it's going to end. Okay, we did this last week.
That is the initializing it for the branch,
Right,
the conditional
right.
registers.
Yeah, so here is where it's going to use for branch check. So when if you already have a positive value in it, you add a 0, it still remain positive, then it's going to check for the branch, then it's going to keep going. But if you have a negative or a 0 there, it's going to send it to the end, the end section. Okay. So here we're going to have it branch for negative and 0. Then we're going to add 0 to R1 again for branch check once again, right? Because think of x times y, and x is 0. We've done this last week, and y is R1. So when you multiply them, you need to check to see which one is positive or negative, right? Then we clear R2, that's going to be our product. Then we're going to loop it, because multiplication is addition multiple times. So what we want to do is we're gonna add R0 to R2. We're gonna count down branch positive to mult loop. As long as it's positive, it's gonna go, right? And then if it's negative, it's gonna go to N, return from the function multiplication. Okay. Then division is very similar to that. You have the x divided by y, right? So you initialize R0 for x. So it's going to add whatever that's there with the 0. If it's positive, right, then it's going to go. If it's 0, it's going to go. If it's negative, it's going to end. Then we are going to have the initialize the divisor now, right? The y, like if you take x divided by y, so R1 is going to be the y. Add it with the 0 for branch check. If it's positive, it's going to keep going. But if it's negative and 0, it's going to end. Okay. So then we would set up the 2's complement. And the 2's complement now is in R1, because division is about subtraction multiple times. And R2 is going to hold the output. So we clear R2. We're going to make it loop for the division. So we would subtract R1 from R0 until R0 is 0 or negative. Then we branch negative to div n. And then if it's 0, we're going to send it somewhere else. That would be no remainder. Okay. So if it divides evenly, then you're going to have it go to no 0 or no remainder, where it only has a quotient. Okay, if it has a remainder, we have to start a remainder. So add 1 to the result, branch back again to loop. So you did an unconditional branching here. Then next, we're going to add the final number to the result. So that's going to give you, you're going to add 1 to R2. So R2 is going to have the final number. And then R0 is gonna, so this will make your remainder 0 after R1 is added. So when you add R1 here, right, you're gonna even out, so there will be no remainder. And then for the division n, you would have the 2 complement to make it positive again. And we done this last week as well. So that makes the remainder valid. And we would return from division. Right, we're not complete until we finish out the Zeller ultimately. So in the Zeller section, because earlier we had it JSR to Zeller. So we would then have R0, we would load the K to R0, and we would load, right, quotient of M to R1. We add these, we load D, we add them, we load quotient of D, we add it. So what you're doing is you're loading the label to the register and then you add that register and you keep doing it until you have the complete formula. Okay. So at the end, after you add the register in, you load a label. Now with the 2C here, you have to add a second time, okay, to make it 2C. And then you would add R0, R1. So now the 2C is added in last. And then you return. So for your N, that just halt. And we did that a few times for the branches. So we want to make sure that we halt there. Then in your data section, you wanted to define your days. And again, make sure that you align it perfectly. Then on the bottom, you need to fill based on the requirement. So when I did mine, I didn't fill some of the label and that kind of threw it off a little bit. So it didn't store it permanently. So it's important to have these fills. So here's your X is at 0. Your K is at F1. C is F2. D is F3. Your remainder, your R is at F4. Your M is at F5. And then the other labels are subsequent. And then your F is at hex 3106. Mod of F is 07. New C is at 08. And then we end the program. Okay. So once you have your complete program, you need to assemble it. Okay, so make sure you go translate, assemble, or you can click the ASM button right here on the right. That would assemble. And if you use an online one, you just make sure that you load your program into the editor and then assemble it. Then once you have that, then what you're going to do is you are going to, let me reinitialize my machine. Okay. Then you are going to go load program, find your program. Before you run it, make sure that we set it, and we talked about this before. So the first location is hex 31, what is that, F0. And then you can put in the day. Okay, so we talked about, let's say that we do the first one, which is March 4th, 1956. Okay, so I would start with the March. So I would do hex 3 for March, and then at 31, we would then hex 4 for the day. And then if I wanted to know the year, so I can do 19, what was it? 1956. So you punch that into your calculator. So start with the decimal, 1956. That will be a 7A4. Seven A4. Okay. So I can jump to those locations, make sure that everything is valid. Then I run. Then I check my console and it tells me it is Sunday. Then I want to check it online. Okay. I put in what day is March 4, 1956 to Google, and it tells me it is Sunday. And voila, it's done. It's correct. Any question? Okay. So in this exercise, what we've done is we come back to division and multiplication, which we worked on it a few times. We also worked on having subroutine and calling subroutine and looping. Okay, so as you can see, this requires a little bit more complex approach in that we use a longer equation, making sure that we set up, right? We start with a number and then getting it to represent the inside of the parenthesis and then expanding out your equation. And then at the end, you would have the complete equation set up to calculate our date. And then we also did mod 7 to convert the remainder value to string. And so you often see Zeller formula being used for days of the week. Okay. All right. The only thing that this one is lacking is save and restore. I mean, there's some load and that, and you would see that that's how you can get about doing it. But you can also set up arbitrary location and be able to load it as well, like what we've done previously. So if you wanted to use like register 5 and 6 in your project to make sure that you use that and then restore from it, you can also do that. Okay. And I will look for save and restore procedures in your program. Okay, so I have a little bit of time left. Do you have any questions? I wanted to expand on your project documentation because we didn't have time to cover that in the last session. So, and then maybe if you have questions about other things, we can address it.
Yeah, I think she liked that again. Hey Alex, just try and find the line of the code where you had the error, and then go back and check on what's it called? On the code that she put up on Canvas. It should tell you.
Thank you, Alan.
Yeah, no problem. She DC'd. Yeah, I think she crashed. I think class is over after 15 minutes ends, so you just gotta wait.
In the meantime, do any of you guys have groups already potentially started?
I haven't yet.
Me neither.
I'm a huge introvert, so I'm like gonna take this opportunity to just be like, if any of you guys want to join a team and don't have anybody, please add me. Like I already started it on the thingamabob. I was planning on doing the grading one because that seems like it'd be pretty easy. So if anybody wants to do that one and wants to join my group, like let me know, please.
I'm fine with it.
Hey, I haven't even checked it. Wait, where's the how do we get there? Is it just on Canvas?
The modules should say like class pop project, and I think it's a group sign up.
Yeah, it's on Canvas.
Are you guys in
It's
the
a Google
Discord?
Document.
Are you guys in the Discord for this class?
I am.
Because we can always help each other out there.
I am.
Yeah, I'm probably gonna review everything before I start going in the group.
Yeah, exactly. I'm gonna be testing like some stuff, like the low key stuff, like just the loading and the storing and how all that works, so I can actually build the program. Yeah, I can send the link. Hold up.
By the way, whoever started the Discord, you are a godsend because, like, oh my gosh, I have gotten stuck so many times, and it was thanks to you guys that I was able to go on.
Somebody DDoSed her, bro. I don't know. Yeah, no problem. I'll probably be telling Rock to make some more rooms too, and then whenever you guys want to work with your groups, you can just go on there and then I'll talk and stuff. It's way easier than some Canvas group chat. Wait, whoever was talking that said the group sign up thing, you said it's in modules and then where?
Yeah, check
So
it
if
like
you go to
in,
the very end,
The very end? Oh, the self-team evaluation stuff?
it's
Okay.
either there or check in the first part.
Yeah, which one do we
it was
click?
the first one.
Oh,
Yeah,
it's the
so if you
first
go
one?
into the last module, in the very first one that's there, it's gonna be like the second link that she has in the description.
Oh yeah, the team sign up document. Oh, okay, I found it. Oh, she has like a whole Google Doc sign up. Let's see. Wait, she said we can only do maximum of 3, huh? Oh yeah.
I believe so.
I like how you started at team 5. But
So, Alex, you're fine with me joining your group, or have you already reached 3?
I don't think anyone's joined. Like when I had gone on, there was only one other person who had done anything on the added anything on there. So yeah, go ahead and join, please.
Have you added yourself somewhere on there?
Yeah, so mine's is team 5. Like yeah.
Is the professor coming back?
If she's having situations like I've had where I accidentally knocked something out or I didn't charge my laptop, might take her a minute. I'm gonna wait the 15 though.
All right, I've joined your group.
Thank you so much.
Are you in the Discord server?
Yes, I am.
Yep, I'm also there under the handle Monsoon Junior 99.
I'm going to be sending you a Discord message right now.
How many people are the groups for?
Max of 3.
Oh, 3.
Hello.
I think she left again.
I guess she's still having some sort of internet issues.
Okay, so I'm on my mobile phone and I'm not able to get my internet connection reestablished with Spectrum. So usually about this time is when sometime we have issues. Possibly it's just the line for distributed in the neighborhood. So I'm not able to go over the project with you because I wanted to point out the sections and such. But before we get sent off for the rest of the evening, do you have any questions regarding your lab?
Not really. Should we all type our names in the chat now? Can you see it?
Yeah, not at the
Yeah,
moment.
so the chat and everything is the recording sessions. It's still gonna go as I already started as a host at the beginning. So if you type your name into the chat, it will still record in my chat log, regardless of how I connect. So if you want to do that, and I apologize, and this is part of the issues with virtual environment, but what we will do is I will touch base with you again for the project documentation when I have in the next session, possibly with better internet connection by then. Okay. All right, so make sure that when you finish the lab, make sure you check the dates and go through your code and understand your code, and then answer the questions and provide the screen captures. Okay. Thank you so much. Have a good evening, and I'm sorry.
Hopefully we'll be back on campus soon. Like, I got
Yeah,
my
so
first dose of the vaccine last week.
yeah, so we have already submitted our schedule and we're getting ready for fall. So fall will be the first time that we're going to return for 80% on campus.
Good.
Okay. All right. Thank you guys. Thank you everybody. I'll see you next week. Yes.
Oh,
Okay,
how would the
do you know-
80% work like when we come back on campus?
I guess the courses, we have to book them as face-to-face courses, and it's really up to the faculty on how we wanted to conduct our courses. We were told that we can still stream them like via Zoom or, you know, using the campus networks, and they had upgraded our system with webcams. We do have hybrid and online courses still, but those are only going to be 20%. The face-to-face will be the majority of the courses like what we've done before. So what, you know, regarding student in class, I guess everybody would still have to wear mask, and, you know, they didn't say anything about social distancing, but I know that they told us that we are required to wear a mask. And then if there's any additional stuff like shields and things like that, that will be really the faculty requests, cleaning products, gloves, wipes, etc. So every faculty would need to require that for the room that they teach in. And they do have those products available in the hallway and stuff like that too. But as far as, you know, if you can't make the session, I think for my classes, I plan to still Zoom it and teach in the regular class environment at the same times. For the classes that require equipment, you know, that will be a little bit more helpful to be back on campus. But other than that, you know, we have to schedule it as a face-to-face class. So I suggest talk to the instructor and the faculty that you're gonna have. Okay, on how they want it
Professor,
to. Yeah. I'm sorry.
I was gonna ask if are they gonna make us take the vaccine now? Like, is it mandatory?
I don't know if there is gonna be a requirement like some of the other requirement, like, you know, how you have to get tested for TB before you tuberculosis before you start at any school. I think that requires regulations to be passed. So right now, I don't think that there's a mandatory vaccination required. As you know that many places they even say that they recommend that you take the vaccine, but it's not passed as a law yet for a lot of public institutions. Until it does that, I don't think that they can mandate it, but they can probably, people can probably refuse certain things, but, you know, then that gets into some legal requirement. So for now, all I know is that our district hasn't said anything about that until I'm thinking that that might be they're waiting for certain laws to be passed, because I think the majority of the people still haven't gotten vaccination. But if you are interested, I know that this Friday there was an email that came out that they're doing vaccination on campus at Moreno Valley College, and they were doing it in different places, like RCC and Norco. But if you decided that you want to wait out on the vaccine, maybe you have to just be careful. Okay. But I'm getting my second dose tomorrow.
I strongly recommend everyone get the vaccine.
Yeah, and I think right now they can't enforce it, but because even though there's not enough places to do that, so I think probably down the line, like a few years from now, or maybe a year from now. But yeah, but it's just like the flu. So you were, if you're vaccinated, you're good for a while, and then you still have to get revaccinated. So okay, all right. I know that most of our CIS courses will be on campus. There are some that are online that's being taught by our part-time faculties and things like that. But I know that I'm required to be on campus at least 75% of my teaching assignment. So any other questions?
Have a great weekend, Dr. K.
All right, you too. Take care. Have a good night, everyone. I'll stick around for questions if you have questions. Thank you.
Oh, Professor, I wanted to ask, when we were loading the C stuff, you know how we load before we store?
Mm-hmm.
What is the point of loading the register? Is it to initiate the variable?
Yeah.
Oh,
Well,
okay.
because you're using a label. Remember how we loaded before?
Uh-huh.
And then we're gonna do something with that register. So the label is at a location, and you gotta load the register so it ties with that label.
Okay. Oh,
Yeah,
so we're
and
more
then
like taking the R0 and then the C goes to that R0, right? So we're
right,
loading C into that
yeah.
register.
You basically point when you did an LDI, you point to that location,
Mm-hmm.
right? And then you do something with the register, and then afterwards you have to store it back to that location so it will be permanent. But if
Okay.
you start with the store, then you have to load at the end. So if you load at the beginning, you have to store out, right? Because otherwise your data would not be in a permanent location. But
Yeah.
if you store at the beginning, basically you retrieving from that location, and then you do something with it, and then you're gonna load it at the end.
Okay. That's all I have. Thank you,
Okay.
Professor.
You're welcome. Any other questions? Let me know if you have any questions. Thank you. Have a good night, Eric.